All right, in this video, I'm going to walk you through 2008 parts A, B, and D. Okay, and this relates to intermolecular forces and solubility, and then also intermolecular forces and boiling points. So the first part of the question asks you to compare the structures of pyridine and benzene. So pyridine's on the right here, and on the left, and benzene is on the right. You're told that pyridine is soluble in water, but benzene is not soluble in water. And you're supposed to account for the difference in solubility. So explain why pyridine is soluble in water, but the benzene is not. And in your response, you must discuss both substances in your answer. So what I've found is that when you are writing a long paragraph that is very descriptive, where you have to discuss two different substances and their interactions with the solvent, in this case water, students tend to say a lot of things right and then perhaps one thing wrong. And that one thing wrong can negate your entire point. It can negate everything that you said correctly. So instead of writing a paragraph, what I've found and what readers have said that they prefer is an organized chart where you go through and you compare each of the substances that are being asked about. And then that way it's more organized for you, it's more organized for the reader, and there's less of a chance that you're going to make a mistake either by not including something or by including wrong information. Okay, so what I do is this. I've got my two solutes, the pyridine and the benzene, and I'm just going to go through and talk about each one based on the Lewis structure, and then how it interacts with water, okay, because that's what we're supposed to explain, why the pyridine is soluble in water, but the benzene is not. All right, so the first thing that we want to look at is the polarity. So based on this Lewis structure, pyridine is polar. It is an asymmetrical molecule, so bond dipoles do not cancel. And we can see that right here, okay, right where the hydrogen has been substituted, or where the carbon has been substituted with nitrogen. That's going to cause the asymmetry. Whereas benzene is non-polar, so there is molecular symmetry. So bond dipoles do cancel. Okay, so right off the bat, I can kind of narrow down what kind of IMFs pyridine has versus what kind of IMFs benzene has. Okay, so now let's talk about the intermolecular forces. So if you have a polar molecule, then obviously you're going to have dipole attractions. And then you also need to notice that pyridine can hydrogen bond with water. It cannot hydrogen bond with other pyridine molecules because the hydrogen on pyridine is not directly bonded to FO or N. So pyridine can't bond to other pyridine molecules through, or can't be attracted to other pyridine molecules through hydrogen bonding. But hold that hydrogen bonding in the back of your head for just a moment. Okay, benzene has nothing. It's nonpolar, so it's going to interact with other benzene molecules through London dispersion forces. And you can abbreviate that LDF if you want to call that induced dipole. That would work as well. Okay, so I've gone ahead and I've started differentiating the two solutes. Okay, so next, how does water interact with itself? Because remember, dissolving is a three-step process. You have to separate the solvent, you have to separate the solute, and then you have to put the solute and solvent together. So I got to talk about IMFs in each of those steps. So I've talked about the IMFs within each solute. Now I'm going to talk about the IMFs within water. So water is polar. Therefore, you don't even have to write this in complete sentences. Water can form dipole-dipole attractions to other water molecules, but more importantly, it can form hydrogen. Hydrogen bonding can occur between water molecules. And so that's a relatively strong attractive force, all right? Okay, so now we have to talk about how will and this really is the most important step, how will the solute and the solvent interact? So let me do the easier one first. Benzene is nonpolar, water is polar. So those can interact, benzene and water can interact through dipole, induced dipole interactions, or they can just, everything has London dispersion forces, even water. So water can interact through LDFs with benzene. On the other hand, let me go back up to the structure. Pyridine can hydrogen bond with water. The hydrogen on water, either one, can be attracted to this lone pair of electrons right here on nitrogen, and you can make your hydrogen sandwich where hydrogen is in the middle and your bread pieces are oxygen in water and this nitrogen in pyridine, okay? So in terms of how the solute can interact with water, we can say you can form hydrogen bonds with water, which is a good thing in terms of the two of them interacting. They can form dipole attractions, and they can also have just LDFs. Everything has LDFs. Your primary method or your primary intermolecular force that's going to cause the interaction between pyridine and water is going to be hydrogen bonding or dipole-dipole attractions, okay? So is pyridine soluble in water? Yes, you're told that in the question. So read the question, read the prompt, okay? Is benzene soluble in water? No, you're told that in the question, okay? And now we're going to, obviously do not write this in your response, but just go through and say, yeah, it's soluble, or no, it's not. But make sure you go back and read the question. You're usually told if something is soluble or not. You're asked to justify why something is soluble in a solvent or why it's not soluble within a solvent. Okay, so here's the justification part. All right, so pyridine can interact with water through hydrogen bonding and dipole interactions. These attractive forces are strong. They are strong, and therefore the solute can interrupt the hydrogen bonding in water to form new solvent attractions. Okay. This right here has to be as strong or stronger than the IMFs within the solute and the IMFs within the solvent. Okay, so why can benzene not dissolve in water? Benzene can only interact with water through induced dipoles or LDFs. These forces are not strong enough to disrupt the hydrogen bonding in water. Therefore, benzene is not soluble in water. And there is the answer to the first part of the question. Now, I know that's a long explanation through me talking, but to be quite honest with you, this chart is way more organized than a paragraph. And it's a lot easier for you to quickly go through and read and write, and for, more importantly, for the reader to read and make sure that you understand what you're doing. So let me zoom out of this so you can see the parts. So I have the solutes at the top, and your chart does not have to be set up this way, but it does have all the relevant parts that you need. Your Lewis structures, so that you know, okay, what the heck am I talking about? And you're relating properties and IMFs back to the Lewis structure, sort of that structure-function relationship. Is it polar, non-polar? That kind of narrows you down in terms of what IMFs can the solute have with other solute molecules that are the same. The solvent IMFs, what does water have? And then how does the solute and the solvent interact, those IMFs? And then is it soluble or not? That's yeah, yes or no. And then your justification for why it is soluble and for why it's not soluble. Okay, so I'm going to post this and then we'll work through some more of this in class.